All right, students, today we're going to learn how to conduct the Anova procedure, which is the analysis of variance procedure. So let's just say I want to know, does there appear to be a relationship between your education level and the age when your first kid is born? Okay, so let's just say that I believe that if I were to take a sample of all these different groups of women who have graduate versus bachelor versus associates versus high school versus less than high school degree, I might have an opinion that one of the means is going to be different from the other. So let's just say I believe that as your education level increases, the average age when your first kid is born is going to be higher. Okay, and women who have lower levels of education, the average age when they have their first kids is going to be lower than people who have higher levels of education. So what I can do is I can conduct the Anova procedure, okay? So what I would do is, let's just say I'm just looking at women. Well, the first thing I'd have to do is I'd have to alter the data and only analyze women. So I don't necessarily cut the women, or I don't necessarily cut the men out of the data set. I cut them out of the analysis. So how am I going to do that? I'm going to come over here to this data section. I'm going to click data. Now I'm going to select cases. And then I'm going to click on if condition is satisfied. So I'm going to click if condition is satisfied, then I'm going to click if. Okay. Now, in order to get just women, now I know that women in the data set are coded as 2. So for the variable sex, so I'm going to put sex, then I'm going to put equal sign, and then I'm going to put 2, press continue, then I'm going to press OK. So what that means is that if this condition is satisfied, that is if you are labeled as 2 in the sex category, the sex variable, then you will be a part of the analysis. For everybody who's labeled as 1, who's a male, will not be in the analysis. So that's the first step. Now the second step that I'm going to do is I'm going to come over here. So as you can see, SPSS is checking off everybody who put down 1, so everybody who I identified as being a male is being cut out of the analysis right now. So what I'm going to do is I'm going to come over here, I'm going to click on Analyze, and then I'm going to come down to Compare Means. Compare Means, and then I'm going to click on Way Anova. And display variable names. Now the dependent variable is age when kid was first born. So I'm going to put this variable age when kid was first born into the dependent list, and I'm going to have my independent variable is going to be degree. So I think when we look at degree, there's less than high school, associates, bachelor's, and then graduate. So those are the 5 different categories of that variable. So those are going to be the 5 different samples. So they're going to treat each one of those categories as a sample in and of themselves. Then it's going to compare the means of those different samples to see whether or not the means, whether or not it's plausible or probable to think that the means are all equal in the population. That is the mean age when the kid's first born for these different groups, for these different samples. Okay. Now, one other thing that I'm going to have to do is I'm going to have to click descriptives. So I'm going to click. I have to come over here to options in the upper right hand corner. I'm going to click on descriptives in the statistics section. I'm going to press continue, and then I'm going to press OK. Okay, now it's just provided me with the information that I need. So 618 women answered this question. Okay, and so this is the sample of less than high school, sample for high school, sample for junior college, sample for bachelor, and sample for people who have graduate degrees. Now, as you can see, the women who had less than high school degree, the average or the mean age when the first kid was born was 19.58. For high school, it goes up to 22.04. For people with a junior college level of education, it goes up to 24.52. For women with bachelor's, it goes to 26.28. And for women with graduate level degrees, it goes up to 27.42. So there's, looking at the means, just doing a comparison of the means, there certainly looks like there's a relationship here. But obviously, you don't just want to look at the means. The purpose of the Anova procedure is to determine mathematically whether or not it's probable or plausible to think that the means are all equal in the population. Okay. Now, the way we go about doing that is by calculating the F ratio, or the F obtained. So what we have here is we have the between group degrees of freedom and the within groups degrees of freedom. Now, like I said, if you were hand calculating this, you would use those degrees of freedom. The between groups would be degrees of freedom 1, and then within groups would be degrees of freedom 2. Okay. And then you would find the F critical. And then you would compare this F obtained, this 38.392, to the F critical. But we don't need to do any of that again because SPSS does it for us. So the significance level is 0.000, which means that we can reject the null hypothesis at the 0.05, 0.01, 0.001, because again, we can think about the significance level as our p-value that's trying to get below that 0.05, 0.01, or the 0.001 alpha level. So we know that we can reject the null hypothesis. We can reject the idea that the means of all these different groups are equal to each other in the population. Okay, and you can also just kind of just look at the different means, and you can tell obviously that as your education level goes up, the mean goes up. That is the average age when your first kid is born goes up as your education level increases as well. This is a pretty short video, so that's how you conduct ANOVA.